So before we even talk about the video growth, let's first look at the general data growth. In this chart, the green line shows the computer supply that either store or process the data. And then the blue line shows the actual demand of the data growth, which is in exponential. In the past 50 years, Moore's law has really helped us in the sense that we have cheaper and cheaper hardware and faster processing power so that we can keep up the supply with the demand. However, we start to see a gap in recent years, and the gap is widening now. This not only means that we're on the risk of growing out of the space to store the data, but also means that we need to build more computers, more data centers, and building more means we need to consume more, like more power, more cooling, and more spaces. Such solution of simply build more is not sustainable. The video growth is on a very similar boat. If I could bring you the memory back to last spring, where there is a lockdown in the country of Italy, 70% more time were spent across apps since the crisis began. And in a single week, we saw the live views on both Instagram and Facebook app has doubled. Such trend of video streaming growth is not only unique for Meta. In December 2020, more than 120 million people streamed their YouTube service. And Cisco also estimated by year 2022, 82% of all the content created in the internet would be video. This brought a great challenge to keep up with this growth. That means we need to build more efficient hardware, more accelerators, as well as we need better software optimization. So today, I'm going to take you through some of the details on how Meta is optimizing its video storage growth. Also, I'll pause here to see if anybody has any questions for the first part. All right, if no questions, let's continue. So to understand our solution, we need to first introduce a couple of concepts. The first one is the video storage policy. Oops, sorry. So given any Meta video, we usually will create multiple encodings. These include progressive encodings, multiple -ABR encodings across different codecs. A naive policy would be, let's store all the encodings we ever generated forever. And that's exactly what we did in early days. And we soon find ourselves go out of space in the growth rate in Meta. So over the years, Meta has merged into a storage policy referred as Source plus MVE. In this storage model, we only store two encodings permanently. The first one is source encoding. This is a ultra high quality encoding that we use to generate all other encodings. In Meta, we are able to kick off the encoding jobs in an on-demand fashion based on the popularity of the video. So for less popular video, we'll at least get the H.264 lanes. For a video that gets more watch time, we'll produce the, let's say, VP9 lanes, because the cost of VP9 is much higher than H.264. And these encodings are stored ephemerally. So over time, they will be gone. The second encoding that we preserve permanently is called minimum viable encoding. This is like a medium quality encoding that can be either progressive or dash. So how do we preserve the source encoding? Depends on the creation time of the video. We have different approaches. For newer VOD uploads, the source is a sanitized copy of the original input. All the video that comes to Meta will go through an inspection flow If the video is good, then we'll do a simple transmaxing and preserve it as is. If it's bad, we'll first try to correct it through a transcoding process. And if that doesn't work, or the input has certain violations, we'll reject the input. And for older VOD, because the source encoding or the source input is long gone, what we'll do is we'll find the best available encodings that present and then promote it to a source. As for the minimum viable encodings, we have two different models. In the first model, the MVE is a SD progressive encoding, and then the source is a sanitized copy of the original, which is usually not good for deliver. And because the MVE is a progressive encoding that is compatible with all the devices, this model will have 100% device coverage. And then the original quality source will guarantee that we have a perfect source to regenerate any other quality encodings. In the second model, the MVE itself is a SD quality dash encoding, and the source is a HD quality dash encoding. And these two dash encodings will form one ABR manifest, which is better supported by our players. And this model also has a higher potential for the storage compaction, which we'll discuss later. So that's I'll pause here for any question about the storage policy.
Jimmy, I got a question for you.
Go ahead.
Yeah, you mentioned that the source, the videos could be ephemeral, means that they will stay there for a while and then will be gone. So what if a user coming back in 2 years and say, hey, where's my video, or 3 years? So what's my video uploaded 3 years ago? So we won't have the original one, right?
Right. So I want to mention again here, we only have two encodings permanently, and that is the source encoding and the MVE encoding. That means that if other encodings all expire, let's say after a certain time, and the user come back, we'll kick off the encodings generation from this source encoding, because this source encoding is the maximum quality we ever get from the user. And then we kick off the encodings on the on-demand fashion, so we can regenerate any other quality, dash or progressive. And that's and then this is generated encoding will be the one that we serve to the user, even after the video has been old for quite some time.
I see. So the original source encoding is still there.
Yes.
Just the other derivatives are.
Exactly.
Got it.
Yeah. So I think this is the main concept of the storage policy, that we always preserve a source so that we can guarantee anytime the user come back and we'll have something to you regenerate other encodings.
Maybe a follow-up question is how long you keep these derivatives?
Yes, so the derivatives depends on the TTL we set when we are creating the encodings. This can be from 30 days, actually from 4 days to 90 days. We'll have the capability to further extend it, but in general, most of the encodings will live on a 90 days TTL.
Got it. Thank you.
Mm-hmm. Okay. If no other questions, I will continue with the next concept, which is video lifecycle. And the video lifecycle, the system that we developed to manage the video lifecycle to realize or materialize the storage savings is called Video Lifecycle Manager. So here is a simple illustration of video lifecycle. All meta video will potentially go through three states: recent, hot, and cold. The video will enter the recent state soon after the creation time. In the recent state, we still have the ingested original input, and we will start to produce the source encoding and the MVE encoding from the ingested source. And to improve the user experience, we also produce a low-cost basic ABR. So if the video gets enough watch time, it will enter a hot state. So in the hot state, apart from all other encodings in the recent state, we also kick off other advanced ABR encodings that generated from the source. So over the times, these advanced ABRs will expire. And then if the video gets no watch time or little watch time, and it will enter the cold state. In the cold state, all the ephemeral encodings will eventually expire, and only the source encoding and MVE encoding will persist. The state transition between these three states are typically like this. All videos will go through the recent state at upload time. Only a small percent of video that get enough watch time will enter hot state. And if the popularity dies down, we'll go back to the cold state. And majority of the video that receives no watch time or little watch time will directly transition from the recent state to the cold state. And only rare cases where a video that in the cold state will regain popularity and re-enter the hot state. So once the video gets to the cold state, there are many things that we can do to save the storage. And the system that we developed to materialize a storage saving is called Video Lifecycle Manager. It starts from this video asset catalog that tracks all the videos that ever created on Meta. And then through a data query job, it will filter out some of the irrelevant videos. The output of this data query job will be the input to the Video Lifecycle States Manager. The States Manager will inspect what state the video is currently in. If it's already in the cold state, and will take some actions to manage the encodings through some static rules that are written in the Video Lifecycle config. If the video is not yet in cold state, we'll mark the state, and the video will go back to the video asset catalog and restart inspection flow. Let's dive down into some of the key modules in the Video Lifecycle Manager. The first is the Video Asset Catalog. This is a giant database that tracking all the video assets created across Meta. So we're talking about a scale of billions of video. All the columns can be broken down into 3 buckets. The first is the video properties. And these are some of the basic information of the video that uploaded. These include video product ID, video duration, video permanent bytes, and creation time. The second bucket is the video lifecycle properties. And these columns are understood and managed by the Video Lifecycle Manager. The third bucket is the video consumption info, which usually comes in a format like watch time in the last X days. And this is an indicator of the popularity of the video. The second is the key module is the encoding manager. Once the video gets to a cold state, there are many things or actions we can take to cut the storage. And these include reduce semantic replicas, purge, and recompress. Let's take a look at each of them separately. All the encodings at creation time will have 2 replicas and stored in 2 different regions. Once the video gets cold, it's probably not efficient to keep both copies. So if we cut down 1 copy and only preserve 1 replica, this is called a reduced semantic replica. Such strategies is usually applied to the source encoding because the source size is much larger than the MVE. The second is purge encodings. This is a technique we'll apply to the older VOD, where we're keeping multiple encodings in different bit rates. And what we can do is we can cut down all the middle lanes and only leave the best available encodings and one of the SD quality. So they will become source and MVE respectively. The third one is recompress. This is another technique that we can apply to the source encoding. we can further reduce the size of the source encoding by transcoding down to a lower quality in lower bitrate, lower resolution copy. Note that Recompress always comes with a compute cost. And also we need to make a trade-off between the quality and the storage if we decide to transcoding down the source. So this is not that straightforward. Therefore, today, Meta only adopted the first two actions to reduce the storage cost. For the video that is already on the Source plus MVE model, we'll just reduce the semantic replicas for the source encoding. And for the older VOD, we'll first purge, so it has the Source plus MVE storage policy, and then we'll apply the reduced semantic replicas to the source. What does the result look like? So the purple line is showing the projected storage growth in the year 2021, and it comes in a couple of exabytes. And we started to roll out Video Lifecycle Manager in early June. You can see that before that, the actual bytes added aligns with the projected storage growth. And after that, we have successfully bent the curve and achieved 112% storage savings. That is technically means that we are having a negative storage growth for the year 2021. So the team is extremely excited about this work, and we didn't stop there. And we think there are some other things that we can continue to improve this storage policy, storage management work. I would like to pause here for any question about the Video Lifecycle Manager.
Is it possible for a video to go from cold stage back again to a hot stage? Maybe some old videos which didn't had enough views, but for some news event, they are now popular and are hot again. Do you guys handle that in your workflow?
Yeah, that's a very good question. So I mentioned here that the video lifecycle will definitely include the one that from a cold state to a hot state. So these are very rare cases. And then we do have a way to handle such cases. Basically, what we do is we'll reduce the source, we'll reduce the semantic replica of the source from 2 to 1. And then if we find out that we make a mistake, and then the video is actually become hot, what we'll do is we will regenerate another copy of the replica and store in another region. So basically we'll reverse that reduction process to increase. So we have two copies again in the for this source encoding. Does that answer your question?
Yes, it does. But what about the other advanced ABR and the stuff that you had for the hot videos? Will those get generated again?
Right. So definitely, the regeneration from the source doesn't matter if the source is like a one replica or two replicas. The replica itself is still, like the regeneration process will still kick off on the on-demand fashion based on the popularity of the encoding, of the video. So let's say that a video gets popular and it's create a lot of views, and that's enough to trigger other encodings. So the source, which is still probably in the one replica region, will start triggering other advanced ABRs. And then once we have these advanced ABRs, we'll start serving to the users. And then the only thing we worry is, what about the reliability of this one replica? If this video is very popular, and are we able to always regenerate from the one copy? And that's why we're doing the, increase the replicas from 1 to 2 again.
Got it. Thank you.
No problem.
Hey, Jamie, quick clarification on the words. What is the ABR stands for?
Yes, sorry. The ABR stands for Advanced Bitrate and adapt, or it's actually a, like a term in adaptive streaming. So when we say ABR, I think we're referring to as dash or HLS. And these are the specs that enable the adaptive bitrate streaming service. And what it means is for like a video stream that we will chop it down to different segments, and each segment will have its own start time and end time, and it will have some metadata to index each of the segments in this fragmented MP4 container. And when we are doing the video streaming, the players, the client will be able to switch between qualities at the boundary of each segment. So it will adaptively select the best quality that fits into the user bandwidth at any given time. So that in that way that you ensure a better video streaming quality than a progressive encoding.
Got it. Have you considered this different question? Have you considered the users? Some user has a lot of storage versus the others, so like a long tail problems. So some user just accumulated a lot of the, like 100 terabytes of the data versus someone just using a few hundred gig. So have you any of these techniques to handle those kind of situations?
Right. I think one of the maybe different companies have different video service, but in Facebook we don't have a general ownership of the video. Once the video gets to the server side, and we'll treat them equally. So there's no belongings of, okay, so this account are occupying more storage than the other, and we'll want to start reducing its use. We don't have such a concept. So what we'll care here is the popularity of the video, and we'll inspect the state of different videos equally. So if even the video is from, let's say, a premium account, but no one is watched that video, and we consider it's a cold video, we'll start to manage them by cutting the storage cost. But I know that in certain services that you have a video storage service, and then different accounts will have different quotas. And then if the account is above the quota, and then you will start to aggressively cut down the storage cost. So that concept doesn't fit in Meta.
Okay, thank you.
Mm-hmm. Sure.
How many views do you need to have in the last whatever X number of days for it to be considered hot?
Right. So I think that like I mentioned here, the video asset catalog is ever changing. It's not static. So as the time goes by and the video age is growing, that watch time in the last X days will also change. So usually we'll consider, roughly speaking, like the video less than 10 seconds of watch time, a very cold video. And then if it's between 10 seconds to 1,000 seconds, we'll consider it's relatively cold. But we don't just look at like one data point. We'll continue to look at the time window of how the watch time has changed over time for each video, and to consider its coldness.
I see. And do you batch the calls to the watch time? Because every time someone watch, you probably don't update the video asset catalog. Right? Do you batch a bunch of watch times for a particular video before you update it to the video asset catalog?
Right. So the video asset catalog is actually updated on a daily basis. So we have log that's to record the watch time for each of the video asset. And then we'll update the video asset catalog on a daily basis from that logging. So basically it's we do batch, and then the batch is happen on the daily basis.
Understood. Thank you.
Mm-hmm.
I have a question. Sorry, it's about this recompress step that you said, if I understood correctly, that it's not enabled. seems a little bit risky, right, to recompress the source. So I wonder if there's like any part that you haven't figured out, or what would it take for you to enable this?
Yes, definitely. I think this is like a third encoding actions we're already considering adding to our video lifecycle manager, and we want to integrate it through what we call a benefit cost model. Basically, like here we need to make trade-off between the compute to transcoding down, and also there is a trade-off between the quality loss and then the storage cost. So we think that a benefit cost model will help us to dynamically make the decisions for different videos. So we don't, like accidentally recompress a source, and then that source is actually becoming popular. I'll mention that in the next slides.
Got it. Thank you.
All right. Thank you for all the questions. And let's move on to the future work. And I will take more questions after that. So the team is extremely excited about the work and the result that we have achieved so far, but we think that we can do better. The one thing we consider doing is co-reduce the source and the MVE. Recall earlier that we talked about two models of the MVE. Today we're on model 1, where the MVE is the SD progressive encoding, and the source is the original quality, which is not good for deliver. This means that the SD progressive MVE is the only encoding that we can serve. So it's probably not suitable to reduce this MVE, because if there is a data outage, and we will have nothing to serve to the user. In the second model, where the MVE is the SD quality dash encoding, and the source is the HD quality dash, this dash encoding will form one manifest ABR. And if we co-reduce the source and MVE and cut down the replica to 1, if any of them is not available due to data outage, we'll at least fall back to the other. This way, we're able to co-reduce to achieve a higher storage reduction. So today, model 1 helps us to achieve about 35% of the storage reduction. Model 2 will help us to achieve 50% of the storage reduction. And the second thing that we are already doing is to integrate the benefit cost model into the video lifecycle manager. So recall early that in the video lifecycle manager, we're using like a static rule written in the video lifecycle config to decide what encoding actions we're going to take. So instead of using a static config, we can replace it with a benefit cost evaluator. And this benefit cost evaluator will take in all the elements like watch time and the storage cost, the regeneration cost, the quality loss if we, if we are transcoding down to a lower quality, and all these as a input to the evaluator. And the evaluator will spit out a decision on what will be the right actions to take to optimize the storage. So earlier we talked about the Recompress, which is not that straightforward, and the benefit cost evaluator will be will perfectly fits into this situation that helps us to make trade-offs. In this way, we'll have all three encoding actions: reduce, purge, and compress. This not only increases flexibility to our video lifecycle manager, but we believe that it also makes the system smarter and achieve a higher storage efficiency. All right, so let's summarize the talk today. So I first take you through the problem statement of video growth, where we see the demand has far outpaced the supply. And then in order to understand our solution, we introduced a couple of concepts, which is video storage policy. And Meta today is on a source plus MVE storage policy. We then talk about the video lifecycle and the system that manage the video lifecycle. And we talk about what is the lifecycle states and how the video lifecycle manager is reading this lifecycle state to manage the encodings through different actions. And we achieved great results so far, but we cannot stop there. Some of the future works are co-reduce the source and MVE and also integrate the benefit cost model into the video lifecycle manager. I hope now you have a better understanding of how Meta is maintaining its storage, video storage, and I'm happy to take more questions.
So I have a question.
Go ahead. Yeah, go ahead.
So I had heard that, because Facebook can receive shared video and it can come from many sources, many channels. And one of the big problems you face in processing is deduplication, because if you try to just view each source as an independent source and without coordination, okay, then you can end up processing the same thing over and over again. I did not see that factor into your lifecycle management comment. Could you please comment on deduplication and how that integrates with this flow?
Sure. I think when you say share encodings, right? So we are talking about video, a user that published like a video in its feed, and then everybody could share that feed into other pages. Is that the resharing you're talking about?
Yeah, and it may not be as clean. It may be an external video that is captured and then shared by many users as though it is not the same. Okay, so I think for the resharing process that within like Meta, I definitely know something about that. We already have the video asset data model that takes care of that. So when you are resharing a video, we're not just create a copy of the video. What we'll create is like a sub asset. So basically, the video data model is like we have different layers, and on top that we have the resource, and the second that we have the asset, and then below there will be the actual video. So once we're resharing, you're creating a new video, but the encodings are attached to the asset level. So that means that resharing doesn't create new encoding. It's still sharing the same asset. That's why we don't have to worry about the resharing process, because it doesn't really create new encodings. Yeah, I was more worried about YouTube and copies and people downloading and then resharing, that type of situation. Yeah.
Yeah, maybe my understanding would not be correct, but most of the, let's say an external sharing to Facebook is through like a redirect, and it will sometimes redirect to, let's say, YouTube, and then the video, the encodings are sitting in the YouTube server side, not really directed in Facebook. And let's say user decides to re-upload that encoding to Facebook, and that becomes the asset of the Facebook video. And that is within the scope that we are taking care of.
Okay, thanks.
Yeah, no problem.
Anyone has other questions, either you can unmute yourselves and speak out, or you can just post it on the chat, so we can answer that questions. Definitely great talk, Jimmy, and we learn a lot, and we can see that some of the work we can use in our own work.
Well, I'm glad to share this with the industry folks. So if anything that will help, and definitely I think it's worth. Yeah, we have been going through the pain of inefficient management of the storage for a while, and we now start to merge onto this storage management through the video lifecycle, plus this online encoding. So the online encoding really help us. Like, we only need to store the source permanently, and all the other encodings will kick off like on the fly, depending on the popularity of the video. So this not only helps with the new videos, but also older videos. If you have the source, let's say that you now start to adopt a new codec, and then you can also apply this to the older videos. So we think that this is really efficient way to manage our compute and the storage for the video.
Have you,
Maybe I had another quick question, really quick question.
Go ahead.
What percentage of Facebook's storage is consumed by video data?
Well, sorry, I don't have that insights information of the exact percentage, but I think that it's a huge amount. Like I would say, maybe more than 2/3 are like a video data.
Okay, thanks.
Yeah.
I got a question. On this talk, you haven't discussed about the different storage layers. Like for example, in the cloud, you have these are just say S3. It has these S3, the normal S3, and there's also what is called the cold storage. By I forgot the name. Shai had to remember that. What's the? Do you move to different layers of the storage itself for different type of cold and hot?
Right. So first of all, I think Meta doesn't use like AWS, but I think that the layers you're talking about is definitely common here. So if you look at the replica definition here, so we do have a cold storage layer, and then we have the warmer storage, and that what we mean by replica. And then in this warmer storage, we have like multiple replicas in multiple regions. When we say reduce replicas, we mean reduce the warm storage. And that reduction needs to take care of like different regions. Let's say we need to reduce both source and MVE, and we need to make sure that that replica reduced that needs to sit in different regions. So if one region goes out of service, and then we'll have at least the other one that we can refer to. So does that answer your question, Chester?
Yeah. So yeah. And I noticed here now on your slides, you had a cold storage here. So
exactly. Yeah. The cold storage is always there. Otherwise that, like if we lose it, then we'll have nothing. It's just the IO access is efficiency is different between the warm and the cold.
I'm curious about the policy between moving from hot to cold, to warm to cold, and what kind of a transition, the policy you have to say, hey, this video hasn't been watched for a long time. You need to move from the hot to warm or warm to cold.
Right. So I think that in this talk, we don't really deal with moving from cold and between cold and warm storage. We're just talking about warm storage reduction. There is a potential that for really, really cold video, we can keep them completely on cold storage. But that comes at the cost of reliability, right? So let's say that video, sometimes that Facebook has this service called like anniversary sharing, and then suddenly like a very old video like 10 years ago will pop up in your feed, right? So if we put them in the cold storage, then it's very likely that the user will not be able to watch it. So in order to avoid that situation, we'll try to not just have a cold copy, then at least to have one copy in the warm storage at this moment.
Got it.
Also, is there any edge caching for the hot videos?
Edge caching, definitely. Yes, we do have that. So when we are talking about hot videos, these are the videos that have the encoding. So when we actively serve, and the CDN cache will definitely help to speed up the latency from the like a request to delivering to the user. And the player is actively leveraging that CDN cache. The storage optimization we are talking here is in a much longer window, not in hours, not even in days. We're talking about like months. So in that case, that the hot videos are already getting cold, and then we're going to reduce the storage cost for these cold videos.
So we've got a question from on the chat, and Thailand said, how fast does the state like fast, recent, and code transition happen? If the wrong state transition is predicted, the video goes viral, how fast can it be react?
Right. So I mentioned earlier that the data query job is running on a daily basis. So that means that the fastest we can act is on a daily basis. So if a video is going viral, and we definitely will see a spike in the past watch time. And the way that we react to this is, first of all, even if it's already reduced, right? So you still have the source. And then we'll kick off the derived advanced ABR directly from this one copy source. It may be not super reliable, but it's still very high reliability. And you will be able to generate these advanced dash encodings, and will deliver that dash encodings to the user. And the only, like Chester already asked this question, like the only thing that matters is the reliability of regeneration from this one copy of the source. In order to make them more reliable, that we will increase to have 2 copies of the source. So in that way, that the reaction is actually instantaneous if the video goes viral, but our storage model will try to respond to make it more robust on a daily basis.
Okay. Any other questions? You can post in the chat or unmute yourself.
If nobody else is asking, I have one more question.
Go ahead.
Previous work, Facebook described an optical storage tier as code tier, and also mentioned that you might be using tapes or not using tapes. What is the current media for code storage tier for video?
I don't have a full context or of the current code storage. And I do know that today we're still using tape. We do use tape, but we are considering to what we say that we want to not just having like single options of the code storage. What we are, today we're talking about like 1 replica, 2 replicas, right? And then we are thinking about having more options that in between. What about like 1.5 replicas? And what does that mean? Is that like 1 region plus 2 code storage, or like having a lower like a IO access for the coder storage? It's not yet. These details are not yet firm. Maybe I didn't really answer your questions. Yeah, so at least today, I think we're still using the tapes.
Okay, thank you.
I think we no more questions, and I would like to thank the speaker, Jamie Chen from Facebook Meta, gave us a great talk on how they handle the video storage. I mean, it's a good topic. And anybody who has dealing with the video storage knows this how hard it is. Yeah, thank you so much for your talk, and thank you for all for attending. So I'll see you next time. Okay, bye-bye.
Thank you.
Thanks, Jamie.
Thank you everyone for coming to the talk.
Okay, bye-bye.
Bye.